In this question, it is given that the mean distance of Mars from Sun is 1.5 times that of Earth from Sun. What is the approximate time required by Mars to make one revolution about the Sun? So we know the equation for or a relation between time period and radius, that is square of time period is directly proportional to cube of radius, or you can write T is directly proportional to R raised to 3 divided by 2. So we can write the time period T2 divided by time period T1 is equal to R2 divided by R1 raised to 3 by 2. Now we can observe what is given in the question. The mean distance of Mars from Sun is 1.5 times that of Earth from Sun. So assume that distance of Earth from Sun is equal to nothing but R. We are just taking it as nothing but R1. And the distance of Mars from Sun is, let's say, R2, that is 1.5 times of distance of Earth from Sun. So 1.5 can be written as 3 by 2. So this is 3 by 2 into R. So we can just substitute this value over here. So T2, so T2 means nothing but the time period of Mars divided by T1, that is time period of Earth, which we know that nothing but 1 year, is equal to R2. R2 we can take it as 3 by 2 times of R, and R1 we can take it as R raised to 3 by 2. So we can observe that we'll be able to cancel this R and this R. So the remaining thing is T2 is equal to 3 by 2 raised to 3 by 2. So that means we know that 3 by 2 raised to 1 by 2. This can be written as 3 by 2 raised to 1 by 2, the whole raised to 3. And we know that something raised to 1 by 2 means nothing but root of that value. So this is root 3 divided by root 2 raised to 3. And we know that root 3 by root 2 raised to 3 means nothing but root 3 into root 3 into root 3 divided by root 2 into root 2 into root 2. And we know that root 3 into root 3 is nothing but 3. So this is going to be 3 root 3 divided by root 2 into root 2, that is root 2, that is 2 into root 2. Now we can just put the value over here. So this is 3 divided by 2 into root 3 is around 1.7 and root 2 is around 1.4. So we'll get the answer as around 1.8.